So let's go ahead and go to the additional exercises for section 11.1, 11.2. So for problem number 1, we just want to go ahead and write the augmented matrix. So I'm going to do 6, 9, negative 2, negative 1. 9, no y terms, so I need to put 0, 3, 6. No x terms, so I need to put 0, 3, negative 10, and negative 3. And for the second one, I'm going to do 10, 8, negative 2, 2. 7, 4, 0, negative 8. And 0, 8, negative 10, and 8. For number 3, we have x equals 3, so I'm going to write 1, 0, 0, 3. Y equals 1/8, so 0, 1, 0, 1/8. Z equals 12, 0, 0, 1, 12. So we're just writing down what the corresponding augmented matrix is. Here we're going backwards. We're now just writing the equations. So this would be a negative x plus 4y equals 3. And this would be a negative 8x plus 3y equals 5. This would be x plus 9y minus 3z equals 7. This would be y plus 6z equals 11. And z equals 8. So we're not trying to do anything else. We're just kind of translating back and forth for each equation. Okay, for each system, I should say. So number 6, an augmented matrix given, determine the number of solutions to the corresponding system equations. Well, this last line would say 0 equals 5. That means there's no solution. So there's going to be none for that one. This one is 0 equals 0. That's an identity. That's a dependent system, so it means there's going to be an infinite number of solutions here. Kind of fading out here at the bottom. So, and we're not trying to do anything else. We're just trying to determine the number of solutions of the corresponding system equations. This, we're going to have z equals 0. Oh, there's a typo. This should be a 0 and this should be a 1. So let's fix that. That would be y equals 9 and x equals negative 3. So go ahead and fix that. That should have been a 1 and that should have been a 0 here. So negative 3 comma 9 comma 0. That's our solution. That means we have one solution. All right, let's turn the page. And now we're ready to do some applications. So Jessica went to Quick Trip and bought 3 large Dr. Peppers and 5 regular-sized Snicker bars for a cost of $16.47. Brandon went to Quick Trip and bought 2 large Dr. Peppers and 3 regular-sized Snicker bars for a cost of $20.22. If P represents the cost of a large Dr. Pepper and S represents the cost of a regular size, use matrix to determine the cost of 1 Dr. Pepper and 1 Snickers bar. So let's first get our equations. So we have 3 large Dr. Peppers and 5 regular-sized Snicker bars for $16.47. So 3 large, that'd be 3p plus 5, they said S. I'm going to draw a line through my S's, otherwise it'll look like 5s. And that's got to be equal to $16.47. That's my first equation. My second one, I've got 2 large Dr. Peppers and 3 regular-sized Snicker bars for $20.22. So that is going to be 2p plus 8s. Again, I'm going to draw a line through my s. And that's going to be equal to $20.22. Now, let's solve it. So I'm going to write this matrix, and I'm going to go ahead and switch around row number 1, row number 2, because I'd rather divide by 2 because these are even numbers. Whereas if I divide by 3, I'm going to get some messy fractions. So I'm going to put the red on top first, and then the blue on the bottom. So now I'm going to divide row number 1 by 2. So that's going to give me 1, 4, 10.11. Next, I need to multiply row number 1 by the opposite of 3 and add to row number 2. So let's get this going. So row 2 would equal -3 row 1 plus row 2. Now, if you need to go off to the side and do this, there's nothing wrong with going over here on some scratch paper and just doing this out, and you can. That'd be -3, -12, -30.33. And then we'll add these together. That's 0. That's -7. And let's do that last one on our calculator. So that'd be -30.33 plus 16.47, -13.86. So if you still need to do that on, you go off the side and do this on some, over here. So you can do that calculation. So this would be 1, 4, 10.11. We now have 0, -7, -13.86. So next I'm going to go ahead and I've got to get a positive 1 here, so I'm going to divide everything in row number 2 by -7. So that gives us 1. Well, I already got the number. Let me just divide that by -7. $1.98. And now the last thing I need to do is get a 0 here. I have to multiply everything in row number 2 by the opposite of this 4 and add it to row 1. So I'm going to go ahead again, put it on my scratch paper. Take negative 4, row number 2. That's 0, negative 4, $1.98 times negative 4 is negative $7.92. And then row 1 was 1410.11. My new row number 1 is going to be 10, and that's add 10.11, $2.19. And so now I'm going to put this matrix here. I have to kind of squeeze it in here a little bit. That's okay. We'll make it work. So remember the first row, or first column back up here was P. That's the cost of our Dr. Pepper. S here is cost of Snickers bar. So Dr. Pepper costs $2.19, and the Snickers bar costs $1.98. So that would be our answer. Let's try another one. Brian and Jaden had barbecue chips and a soda at a football party. Brian ate 3 ounces of chips and drank 1 cup of soda for a total of 700 milligrams of sodium. Jaden ate 1 ounce of chips and drank 3 cups of soda for a total of 300 milligrams of sodium. How much sodium is in 1 ounce of chips and how much is in 1 cup of soda? So, you can use X and Y. I kind of like to have something a little bit more meaningful. So I'm going to let C be the amount of sodium in 1 ounce of chips. And then I'll do S for soda. Again, I'll put a line through it so it doesn't get confused with 5. Now, if you saw 2 lines, then we'd be talking about money. But since there's only 1 line, we're talking about the letter S. This would be the amount of sodium in 1 cup of soda. And I do that so when I get the end and I find C, I know that goes with the chips. And when I get S, I know that goes with the soda. It just makes it a little bit easier. So our first equation would be 3 ounces of chips and 1 cup of soda. So that'd be 3C plus S equals 700. Jaden ate 1 ounce of chips and drank 3 cups of soda for 300 milligrams of sodium. So that would be C plus 3S equals 300. Now you can kind of guess what I want to do is I want to switch around the first and second row. Just make life a lot easier. Because I already got 1 for that C. So when I write my matrix, I'm going to put this one backwards. I'll put 1, 3, 300. 3, 1, 700. That way, step number 1 is already done. I've already got a 1 in the upper left corner. So now I'm going to multiply row number 1 by a -3 and add to row 2 and make that my new row number 2. Again, if you need to go off, do it to the side. Nothing wrong with that. So I've got a -3 row 1. Let's see if I can keep this all here. This would be a -3, -9, -900. Row number 2 is 3, 1, 700. Add them together. My new row number 2 is 0, -8, -200. So this would be 1, 3, 300. And then we have 0, -8, -200. My next step is I need to make this a 1, so I'm going to divide everything in row number 2 by -8. And so row 1 stays the same. I should put that in black. This becomes 0, 1, -200 divided by -8 is 25. And now finally I need to get a 0 here, so I'm going to multiply the second row by the opposite of 3 and add to the first row. So again, going off to my scratch paper here, I'm going to take -3 row number 2. That'd be 0, -3, -75. Row number 1 is 1, 3, 300. Add them together. And that gives me 1, 0, 2, 25. So we have 1, 0, 2, 25, 0, 1, 25. So that tells me C is 225 and S is 25. All right, C was the chips, 1 ounce of chips. S was 1 cup of soda. So 1 ounce of chips has 225 milligrams of sodium. 1 cup of soda has 25 milligrams of sodium. And then that would be your answer.